All right, the directions here say to solve for x. So remember when we have an equation and we want to solve it for x, that means we want to isolate the variable or get the x on one side of the equal sign by itself. So here our equation is 22 is equal to negative 7x minus 8 minus 8x. So what we want to do first is we want to combine any like terms that we have. So if we look on the right side of the equal sign here, we have a negative 7x and then a negative 8x. These are like terms because they both have the same variable. They both have an x in them. So we're going to combine them. So negative 7x minus 8x is going to give us negative 15x. We're just combining our like terms on the same side of the equal sign, so we're not using any inverse operations yet. So then the next line of our equation is going to be 22 equals negative 15x minus 8. Now remember our goal is to get the x on one side of the equal sign by itself. So here, this minus 8, we have to ask ourselves, how do we undo subtracting? Or what is the inverse of subtracting 8? And the inverse of subtraction is addition. So to move this minus 8 to the other side of the equation, we're going to add 8 to both sides. Because remember, whatever you do to one side of the equation, you have to do to the other side. So we're going to add 8 to both sides of this equation. All right, when we do that, 22 plus 8 is going to equal 30. And then on the right-hand side here, the whole reason we added 8 was to move this minus 8 over so we can cross these out. So now we're left with 30 is equal to negative 15x. Again, the goal is to get just one x by itself. So negative 15x, remember that's like negative 15 times x. So to undo multiplying by negative 15, we're going to divide both sides of the equation by negative 15. Because the inverse of multiplication is division. So we're going to divide both sides of the equation by negative 15. On the left-hand side here, 30 divided by negative 15, we'll just type that in Desmos, and that's going to give us negative 2. And then remember, on the right-hand side, any number divided by itself, that just makes a big 1. So here, negative 15 divided by negative 15, that turns into a giant 1. And so now we have negative 2 is equal to 1x. But remember, when we're writing 1x, we don't have to put that coefficient of 1 in front of the x. So now we have negative 2 is equal to x. And now we're done because we successfully isolated the variable. So we've got x on one side of the equation by itself. All right, part B. Again, the directions are the same. Solve for x. So here, our equation is 3 times the quantity, 1 plus 3x, minus 7 is equal to 8 times the quantity, x minus 2. In this equation, we're going to have to use the distributive property. So remember, the distributive property says we're going to take the number outside the parentheses and distribute it or multiply it by all of the terms inside the parentheses here. So we have to take this 3 and multiply it by 1. And we know that 3 times 1 is 3. And then we need to also take the 3 and distribute it or multiply it by the 3x. So 3 times 3x is going to give us a plus 9x. And then we can't forget to bring down this minus 7. We don't distribute the 3 to the minus 7 because the minus 7 there is not in the parentheses. So you're only distributing to the terms inside of the parentheses. So after we do the distributive property, the left-hand side of our equation turns into 3 plus 9x minus 7. Now we're going to go to the right-hand side of the equation, and it looks like we need to do the distributive property again. So remember, when we do the distributive property, we're going to take the number outside the parentheses, the number being multiplied by the set of parentheses, and distribute it or multiply it by each term inside the parentheses. So when we do that, 8 times x is going to give us 8x. And then 8 times negative 2 is negative 16. After we've done the distributive property, now we need to look at the left-hand side of our equation and see if there are any like terms that we can combine. So on the left-hand side here, I have a 3 and then I have a negative 7. These are constants, and remember constants are like terms, so we can combine them with each other. So 3 minus 7 is going to give us negative 4, and then we just bring down the plus 9x. On the right-hand side of the equation, we don't have any like terms that we can combine because 8x and negative 16 are not like terms. They don't have the same variables, so we're just going to bring down the right-hand side of the equation. And now we have negative 4 plus 9x is equal to 8x minus 16. All right, so the goal is to isolate the variable. We want to get all of the constants on one side of the equation by themselves and all of the x's on one side of the equation. So now we're going to have to use our inverse operations to start moving things around. So if I have this minus 4, to undo subtracting 4, we're going to add 4 to both sides of the equation. So negative 4 plus 4 is just 0, so we can cross these 4's out. And now on the left-hand side of the equation, we're left with 9x. That 9x is going to be equal to 8x minus 12. We got the minus 12 by doing negative 16 plus 4. So remember, when you're adding that 4 to both sides of the equation, you're adding it to the constant. You have to add it to its like term. All right, then the next line in our equation is 9x is equal to 8x minus 12. So this 8x here is positive. It's like it's being added. So to undo adding, we're going to subtract because adding and subtracting are inverse operations. So we're going to subtract 8x from both sides of the equation. When we do that, 9x minus 8x is going to give us 1x, which again we can just write as x. And then on the right-hand side of the equation, we can cross out these 8x's and we're just left with negative 12. So x is equal to negative 12.